Make sure you have your notes packet out and are following along. I am going to jump around in your notes packet today, so make sure you pause the video if you need to get onto the right page. This grid a lot of you have been using for a long time. It is actually called a Cartesian coordinate plane. Cartesian was the mathematician that really brought this into the mainstream, which is why it is named after him. Most of you either call it a coordinate plane or an XY axis. So if you call it an XY axis, that is fine as well. I'm assuming you know where X and Y is, and the origin is right here at the center, and it is the point 0, 0. And most of this should be review for you. The only thing that might be new is the 4 quadrants. This right here is quadrant 1. It is where everything is positive. Both the x values are positive and the y values are positive. To the left is quadrant 2. And if you can't see that, that's just a Roman numeral 2. Below that is quadrant 3, which is where everything is negative. The x values are negative, the y values are negative. And this last quadrant is quadrant 4. You will have to know the quadrant numbers as we move through this unit, which is why I wanted to show them to you now. The next thing we're going to look at in this unit particular is dealing with equations and inequalities again, but in different forms. A lot of you probably recognize this form, y equals. It's also called slope-intercept. It's in the form y equals mx plus b. The second form here, where x and y are on the same side, is actually called standard form. And we are going to get very familiar with standard form. Most of you should be used to y equals or slope-intercept form. Standard form might be a little bit new. Either way, if you have a solution, it would be written as an ordered pair. Your x is referred to as the independent, and your y is the dependent. Those should be vocabulary terms that you are familiar with already, but if not, make sure you look at that. X is independent. You can set anything in x, and then you would solve for the y. Therefore, your y depends on what you plug in for x. Now, the next thing we're going to do is look at graphing. I'm going to show you stuff in your graphing calculator tomorrow, but for right now, I want to look at a standard form equation and the easiest way to graph it. The easiest way to graph given standard form is to use the intercepts. Now, to find the intercepts, we are going to plug first 0 in for x. If you look at this equation and plug 0 in for x, we'd have 0 plus y equals negative 4. In other words, y is negative 4. Now, it doesn't have to be that fancy. When we plug 0 in for y, think about it. If you plug 0 in for y, that term's going to go away, and you're just left with x as negative 4, which means graphing this, negative 4 and negative 4, is very simple. Now, you might want to get a ruler and draw an actual straight line, but that's how you graph given standard form. So if you take a look at the second one, we're going to plug 0 in for x. If we plug 0 in for x, this term will eliminate because it would just become 0, and you get negative y equals negative 6 or y equals 6. Now we're going to do the same thing, finding the second intercept, except this time we're going to plug 0 in for y. When you plug 0 in for y, this term will eliminate, and you would have 3x equals negative 6, or x equals negative 2. Then simply plot those values, negative 2 and 6, and connect your line. Whoops. Let's try that again. That's a little bit better. Alright, I do encourage you to use a ruler. But that is the simplest way to graph given standard form. And I want you to take a look then down at the bottom of, I believe it's a different page, at kind of tying this all together. Standard form, the actual like written out version, is ax plus by equals c. Whereas slope intercept, this is your y equals mx plus b. Now slope intercept makes one thing easy, and that's finding the slope. The slope is represented by just the m. And if you remember how to graph these, to graph, you're going to start here, and this is going to be your y-intercept. So that would be step 1, and step 2 would be to use the slope. Okay? Now in standard form, your slope is actually the opposite of a over b. And I want you to think about this. If you got this into y equals form, wouldn't you subtract ax and divide by b? Same thing. Slope is negative a. Now, a couple things to notate about this one. To graph it, we're going to graph using the intercepts. So we need to find and plot intercepts. A couple things I also want you to notate about standard form. A has to be positive, and A, B, and C have to be integers. We're going to use all this information in a little bit. Your IXL practice is actually going to be on transferring equations into standard form. In order to do that, you need to have your AX term, so your X term first. It needs to be positive, and none of your coefficients can be fractions. Now, here's where multiplying through to get rid of fractions is coming back in this chapter. You do have to multiply through to get rid of any fractions and turn all your coefficients to integers. Now, why would we want to do that? It is actually easier to graph in standard form, and a lot of the equations we work with in this unit after these first couple days are all going to be in standard form, so I would like you to get used to it. The other little kind of oddball thing I want you to remember from Algebra 1 are your horizontal and vertical lines. Your horizontal lines are the lines that when you graph them, they look something like this. They are written in terms of y, and they only have a y-intercept. Now, if you think about walking across this line, the slope of a horizontal line is 0. Compare that now to a vertical line, which is written, oops, that's not quite vertical, which is written in terms of x and only has an x-intercept and a slope. Think about it. Could you walk up this line? Nope. This would be an undefined slope. That's what that means, undefined. So what you're really going to practice today is a whole bunch of graphing. But I want to show you one more thing first. In this table here, I want you to find the x-intercept, the y-intercept, and the slope. And I do want you to pause this video and figure that out. So pause this video, and I want you to fill in this chart to the best of your ability. Now, a lot of this information you should have been able to fill in. One thing, remember, the slope in standard form is the opposite of a over b. This right here is your a value, and this would be your b. So if you look over here, I have negative 3 over negative 4 equals 3/4. Now, what's annoying for this one is finding the x-intercept, because you would have to plug in 0 for y and solve it out, which means we'd have to subtract the 1 and multiply by 3, or multiply by 3 first, that's up to you, and divide by 2. You will eventually find that it's negative 3/2 comma 0. But I'm sure that was a little more annoying than you wanted it to be, which is why, given an equation in standard form, we graph using the intercepts. Those were probably the easiest things to find. When you have slope-intercept form, you graph using the y-intercept and the slope because those were the easiest thing to find. And for horizontal and vertical lines, you need to recognize which kind of intercept you have and the slope to see if it's going to be a horizontal or vertical line. So let's take a look at some graphing. Now, you can label this stuff if you want to, but really, I want you to look at this. If we plug in 0 for x, so that would be our y-intercept. If you plug in 0 for x, so that term would go away, y would be -2. And if you plug in 0 for y, so finding an x-intercept, 0 for y, this term would go away, and you'd get x is -3. All you have to do is then plot -3 on the x-axis, -2 on the y-axis, and connect. Your slope for this one would be the opposite of a over b. The slope would be -2 over 3. This part is not something I need you to identify, but I want you to get used to looking for where it is. Now, this next one is just another example that's not in your notes packet. But again, look at when x equals 0, y is -2. When y is 0, x would be -6. So all you would do is plot -6 on the x-axis and -2 on the y-axis. Bam, there's your line. Kind of. Oh well, you get the idea. Now, changing from there is when you have slope-intercept form. Do you remember for this, you're going to start with the y-intercept, which is at -3, and then you got to count out your slope. If your slope is 1/2, that's up 1 and over 2, and then connect your lines. Okay, so again, here's another example. You'd start at your y-intercept at -5, and then you're going to use your slope. Now, a slope of 2 is up 2 and over 1. You'd want to turn this into a fraction to be able to graph. Now, watch those again if you need to, but I'm hoping this is review. The last type of lines we're going to have are horizontal and vertical. For our x equals 4, you would find 4 as your x-intercept, and because x is always going to equal 4, you would draw your vertical line down through 4. Now for y equals here, we'd want to get y completely by itself so that we could identify the intercept as -2, and then you would draw your horizontal line for your y equals line. Now what I want you to do in Google Classroom is 2 sections, and they are going to be your homework. You're going to do one section of transforming equations into standard form, and another section on graphing in standard form. So I want you to get used to very quickly finding those intercepts. You don't even have to write them down. Just click on the points and graph those intercepts. I will see you tomorrow.